Listen quickly. Alright, we're going to talk about right triangles. Well, this whole entire chapter is about right triangles, but we're going to talk about two special triangles. They are special triangles. They're all special to me, but these are extra special. Alright, here we go. We call it, and we'll talk about that in a second, we call it a 45-45-90 triangle. Some people call it 45-45 right triangles. I just put the 90 in there. 45-45-90 triangle, which means you have a right angle. And what do you think the 45 and the 45 refer to?
The other two angles are 45
Exactly,
degrees.
the angles. 45 degrees here, 45 degrees here. What do you think is true? We've learned this before. What do you think is true about these two sides right here if these two angles are both 45? They're the same. They're equal to each other, okay? And of course, this is the hypotenuse. Let me do this. Let's call this A. We'll call this A. And won't call this anything right now, okay? I'm just going to call this side A. Remember, if this is 45, 45, 90, these two sides are equal, correct? I'm going to come up with a little formula here that we're going to use on both of these special triangles. This is the first one. I could just sit here and just show you the formula and say this is how you use it, but that wouldn't be any fun, would it? It's kind of nice to see where these formulas come from, and that's what I'm trying to show you right here, okay? So it's not like you're going to, what I'm doing right this second is going to be on a homework or anything, but I think it's important for you to see where this stuff comes from. What I want to do is I want to see a relationship between this hypotenuse and the two legs. So let's do this. We already know Pythagorean Theorem, correct? So if I wanted to find out what this hypotenuse was in relationship to these two legs, what would I do? I would go a squared plus a squared equals what? Actually, let's just do this. Let's not even say it's equal to anything. We'll find out what it's equal to. All right. So what's a squared? Actually, hold on. Look. Yeah, we'll call it h for hypotenuse. Very good. Okay, so that's going to be squared. This is how I want to set it up. So a squared plus a squared equals h squared. Well, what's a squared plus a squared? It's 2a squared. Would you agree? Equals h squared. What I want to do is I want to find out what h is equal to. You get it? In relationship to these two sides right here. And I put a because that could represent any number at all, couldn't it? You with me? So if I want to get h by itself, what would I do? I would take the square root, correct? And then I would take the square root of this. Well, how do I simplify that? So h is equal to the square root of 2, what? Times, no, not a squared because it's under a square root. The square root cancels out the a squared, or cancels out the squared. Come on, we've talked about that a whole bunch of times. Remember this? This is like the third day, at least the third day we've discussed this. The square root cancels out the squared, so you're just left with a 3. This square root cancels out this squared, so you're just left with an a. So what do I have right here? What is that a? The a is one of our legs of the right triangle, isn't it? And the h is the what? Hypotenuse. So watch this. The hypotenuse then will always be equal to, watch this formula, the square root of 2 times one of the legs. That's how I'm going to write it. And I just showed you how we got to it. And that's really important. Now you could always go through Pythagorean Theorem and get this, okay? But I'm trying to show you a little shortcut. You know that Pythagorean triple thing? At first you're like, oh, I don't understand it. But then you see it and you're like, oh, 3, 4, 5, that's a lot easier. Okay, it really is helpful. This right here is actually very, very helpful to you. It should be. So let's do a quick little example. Let's shrink this just a little bit. I'm just going to make up a number here. Watch this. What if we put a 3 right here, and I said this side was equal to this side? That's all I told you. That the two sides are equal. It's a right triangle, and one of the sides is 3. And if I ask you to solve for the other sides, what would be the easiest side to solve for? Yeah, down here. Okay? And you got to find the hypotenuse now. Now, you could always go through Pythagorean Theorem, couldn't you? But if you look at it and realize that, hey, wait a minute, what kind of triangle is this? It's a 45, 45, 90 triangle, isn't it? And what's true about the hypotenuse? Look at my little formula. The hypotenuse is always what? The square root of 2 times one of the legs. Well, what do I know here? I know one of the legs. Exactly right. You don't really have to do much at all. You just write 3 square root of 2. Wouldn't you agree it's nice knowing that? Because if they give you this, I don't have to go through Pythagorean Theorem and do this every single time. I did it once. I figured out what my little relationship is, and then all I do is take the leg and multiply it by square root of 2, and I'm good to go. Wasn't that easy? Yeah. Y'all see that, don't you? It's pretty easy. Watch this. What if I said that this was the square root of 7? And I told you these two sides are equal to each other. Find both sides. Well, obviously, that one's the square root of 7 as well, right? What about this one? What's that going to be? It's the square root of 14. That's all it is. Yeah, because it's the square root of 2 times one of the legs. So I take one of the legs, the square root of 7, and I multiply it by the square root of 2. That's my little formula. So the hypotenuse is the square root of 2 times one of the legs. What is the square root of 2 anyway? Square root of 2 is like 1.414, isn't it? Yeah, how about that? So watch, the square root of 2 is 1.4. So what is that telling you? On a triangle, when you have a 45, 45, 90 triangle, that means these two sides are equal. It's an isosceles right triangle, isn't it? Isn't that exactly what it was? Okay, if I have an isosceles right triangle, the hypotenuse will always be about 1.4 times as large as the other legs, or the square root of 2 times one of the legs. Everybody see that? All right, bro. A hypotenuse. Okay, good question. That's what we're going to do. That was next on my list. All right, so what if they told you this was, now you may think this is going to be hard, but it's actually a little bit easier. Watch. If I said this was, the square root of 8. All right, what if I said that was the square root of 8, and I told you that it was isosceles, or it's 45, 45, 90, and it's a right triangle, and you needed to find both of these legs right here. Well, look what your formula says. It says, let's shorten it up a little bit, the hypotenuse is the square root of 2 times one of the legs, correct? But what if you know the hypotenuse? How would you find the leg? You could just plug it in, or just do what? Divide it by the square root of 2. Correct. Do you see that? So it's the square root of 8, what? Divided by the square root of 2, which is, what's that? It's the square root of 4, which is, right, regular 2. So that would be a 2. You say, wait a minute, that's not 2 square root of 2. Well, is it? Think about it. What's the square root of 8? Square root of 8 is 4 times 2, isn't it? What's the square root of 4? 2 square root of 2. Isn't that 2 square root of 2?
Yeah.
Yeah? All right. I know I'm going a little fast, but you got it recorded. All right. You can always go back and watch it again. All right. So use that to your advantage. So of course, if this is 2, what's this? That's 2 as well. Do you agree? Because look, go backwards. Go. What if I knew this? Then what would the hypotenuse be? It'd be 2 square root of 2. But you're like, well, wait a minute. You said it was square root of 8. Yeah, but square root of 8 is the same thing as 2 square root of 2. Same exact thing, isn't it? Yes. That's why I've been harping on this square root stuff the last couple days. All right. All right, that's 45, 45. Let's do another one. It's going to look a little different. This is probably not drawn exactly to scale, but it is a right triangle again. And this angle will be 30 degrees. So what's this angle up here going to be? 60. So what do you think we'll call this triangle? 30, 60, 90 triangle. All right, and there's something special about this as well. All right. I was going to do this, but I'm running out of time. I'm just going to show you what the formula is. All right, because I usually like to show how we got to this formula. Maybe tomorrow, if we have some time, maybe I'll do that for you. But today, I'm just going to show you how to do this so you can start working on this. This obviously is the hypotenuse, correct? Because it's opposite the right angle. What I want to do is I want to look at these two sides. Are these two sides equal to each other like they were in that other triangle? No. This one is what compared to this, do you think?
Smaller.
Smaller. And how do you know it's smaller? Just because it looks like it's smaller? No, because it's opposite the what? Smaller angle. Remember doing that stuff? See, stuff that we learned before is coming back, isn't it? All right, so this is we're going to call this the short side or the shorter side. Okay, we'll just call it the short side. And we'll call this the long side or the long leg. This is the short leg. This is the long leg. Everybody got that? And this is the hypotenuse. That doesn't mean this is the longest side of the triangle, though, is it? Because the longest side of the triangle of a right triangle is always what? The hypotenuse. Okay, so the hypotenuse will always be the longest side. But as far as the two legs are concerned, that's the long leg, that's the short leg. Okay? Yeah, it's opposite the 60, right? So that has to be longer than this one because that's opposite the 30, right? So I have two relationships here. You guys watching? Writing this down? It's important. Here's the easiest one. The hypotenuse, which is kind of nice, is exactly 2 times the short leg. It's twice as big as the short leg. So if that short leg was 5, what's the hypotenuse? 10. Easy peasy, right? Would you agree? All right. What if the hypotenuse was 12? What's the short leg? 6. Yeah, that's simple, isn't it? So it's a nice relationship between the hypotenuse and the short leg, where there's a second relationship, and that's between the long leg and the short leg. They actually both relate to the short leg. So there's a relationship between the hypotenuse and the short leg, and there's also a relationship between the long side and the short leg. So the short leg's the important leg on this right triangle here. It really is. Okay, so watch what we have here. The long leg. So the long leg is equal to the square root of 3 times the short leg. And, well, we would have figured it out if I had about 5 more minutes, but we ran out of time. Okay, I don't know who the first person to figure that out was, but it's actually pretty simple, and you'll see. Hopefully tomorrow we'll be able to go through and show you why this is true tomorrow. But there you go. There's your two relationships. So on a 30, 60, 90 triangle, there's actually 2 relationships, and they both relate to the short leg. All right, so you could put some stuff in here. Let's just do one really super quick here. Bell's going to ring any second, I think. It does ring at 20 after, right? Okay. Well, let's just do this. I don't have really time. Tomorrow we'll answer some more questions if you have some. Watch. What if this is the easiest way? What if this was 5? What would the hypotenuse be if this was 5? This is the short leg. This would be 10. What would the longer side be? Look at the
15.
formula. No. It's not 3 times the short leg. It's the square root of 3 times the short side. No decimals. No decimals. Okay? We're going to say 5 square root of 3. Okay? That's what we're going to write. Now, it gets a little more confusing when they tell you, like, the longer side and you got to find the other ones. But we already talked about that on the 45-45. You just do a little division. All right? You'll figure that out. So let me give you some problems to do. And it's 8 to 25 on that section, section 8.3. 556, 557. 8 to 25.